Let's talk about the redox reactions of ammonia and how ammonia acts as a base. Here, let's first talk about how ammonia acts as an oxidant, and there's one example for it. Actually, we can use any group 1 element except lithium for this position, but we'll take sodium for the example. Here, ammonia reacts with sodium to form sodamide and hydrogen gas. Here, the sodium oxidizes from 0 to +1 oxidation state, while in ammonia, the nitrogen stays in the same oxidation state of -3, but the hydrogen in ammonia, which is in +1 oxidation state, reduces itself to 0 oxidation state in hydrogen gas. Now let's talk about how ammonia acts as a reductant. Here we'll take our first example where ammonia reacts with heated copper oxide to form copper, nitrogen, and water or steam. Here the copper in copper oxide is in +2 oxidation state and it gets reduced into 0 oxidation state in copper, while ammonia, the nitrogen oxidizes itself from -3 to 0 oxidation state. Here we react ammonia with oxygen and we form these gases and water. Here we do so under the presence of catalysts like platinum and rhodium, while in here we do so without the presence of catalyst. When we do so, in both cases, the oxygen gets reduced to water. The oxygen reduces its oxidation state from 0 to -2 in water, while ammonia oxidizes itself from -3 to +2 in NO and 0 in N2. Now we'll treat ammonia with chlorine. Here we do so with limited ammonia. When we react with chlorine, we will get nitric chloride, and then we will get HCl also. We'll get hydrochloric acid as well. Here the chlorine, it gets reduced from 0 to -1 oxidation state, while ammonia gets oxidized from -3 to +3 oxidation state. When we do so with excess ammonia, what happens is first ammonia reacts with chlorine to form nitrogen gas and hydrochloric acid, and then the ammonia reacts with the formed hydrochloric acid to form ammonium chloride. So that overall the reaction is excess ammonia reacts with chlorine to form nitrogen gas and ammonium chloride. And even in this case, the chlorine, it gets reduced from 0 oxidation state to -1 oxidation state in ammonium chloride, while ammonia gets oxidized. The nitrogen goes from -3 oxidation state to 0 oxidation state in nitrogen gas. Now we'll talk about how ammonia acts as a base. Actually, how it acts as an acid as well. Well, here, ammonia, when we expose to red litmus, it turns it into blue litmus. So yeah, this is a very typical example of how we can prove the basicity of ammonia. And when we dissolve ammonia in water, it reversibly forms ammonium hydroxide aqueous, which reversibly dissociates into ammonium ion and hydroxide ions. That is to say, it forms a basic solution. So that's another example for ammonia acting as a base. Here we did this example earlier also. It's actually an identification test of ammonia, where if we were to react ammonia gas and hydrochloric acid gas, hydrogen chloride gas, both of which are transparent, a white fume will form, and that white fume is ammonium chloride. It's a solid. In this case, hydrogen chloride acts as an acid, this acts as a salt, while this thereby acts as a base. Actually, more technically, ammonia acts as a Lewis base, hydrochloric acid acts as a Lewis acid. Here's another one. Ammonium chloride, it can react with acid to form a salt and water. So this is a typical neutralization reaction, and this is another means of showing the basicity of ammonia. Now we will go to the very atypical part where we discussed how ammonia acts as an acid. Here, if we were to take group 1 metals except lithium, like sodium, potassium, rubidium, etc., and react it with ammonia liquid, we get the metal amide, amine. We get the metal amine, and we get hydrogen. Actually, remember our previous example, like we react sodium with ammonia, we get sonamide and hydrogen. Yeah, just like that. And if you were to take group 2 metals and lithium and react it with ammonia, we will get the metal nitride and get hydrogen gas evolve. For example, if we were to take magnesium and react it with ammonia, we get magnesium nitride and hydrogen. We take lithium and have reacted with ammonia liquid, we get lithium nitride and we get hydrogen gas. In all these cases, what happens is hydrogen gas is evolved when ammonia is reacted with metals, and that is something an acid does. An acid reacts with metals to liberate hydrogen gas while forming a salt, metal salts, in this case metal amines and metal nitrides.